Good morning everyone. In this lecture of integration, we will be dealing with definite integral. First of all, we will look at the type of functions, rules, standard results and type of integration. So basically, the type of functions are 5. These are inverse function, logarithmic function, arithmetic function, trigonometric function and exponential function. The example of inverse functions are like 1 upon x, 1 upon x square, 1 upon x cube, sin inverse x, cos inverse x, tan inverse x, sec inverse x. These are all like sin inverse x, tan inverse x, cos inverse x. These are all example of inverse trigonometric function. The example of logarithmic functions are like log x, log 1 plus x, log 1 plus x square, log 1 plus x cube. That is, we are assigning a logarithm to some function, then this will be logarithmic function. And what is arithmetic function? Arithmetic function is also called algebraic function. Arithmetic function is of the form of fx equals to 1 plus x square plus x cube plus dot x to the power n, or like fx equals to ax cube plus bx square plus cx plus d. And what is trigonometric function? Trigonometric functions are like sin x, cos x, tan x, sec x, cos x. These are all example of trigonometric functions. And examples of exponential functions are like e to the power x, a to the power x, b to the power x, where a, b, e are constant. These are all example of exponential function. Now, the arithmetic function or algebraic function are basically, we will be dealing with of 4 type of algebraic function, like monomial function. What is monomial function? When the degree of algebraic function is 1, this is called monomial function. And monomial function is of the form of e to the power x plus b. A square polynomial function is a of the form of ax square plus x square plus b. And the polynomial function px is based on ax square plus bx plus c. There will be a monomial also attached to the square of the function, right? So actually px is also a square function of degree 2, but in the case of sx, we are having 0 coefficient attached to the x. So basically here the coefficient of x in sx is 0, but in the case of px based, here the coefficient of x is b, right? Now higher degree polynomial function or algebraic function or arithmetic function, it is of the form of a to the power a x to the power n plus b x to the power n minus 1 plus up to c, right? Now the rules to solve integration of algebraic function or arithmetic function. First, when we are getting integrand of the form square root of mx, then we will put mx equals to t square. Rule number 1. Always हम किसी भी फॉर्म में when we are getting an integrand of the form of square root of mx, then we will put mx equals to t square, right? Now rule 2 is conversion of px to sx. When we are getting integrand of the form of px equals to x square plus bx plus c, then we will convert px to sx, sx to x square plus b. In this form, we will converting px to sx, right? When we are getting the integrand of the form of mx upon px, that is ax plus b upon ax square plus bx plus c, in arithmetic function, then we will express mx equals to lambda p dash x plus mu, where p dash x is the differentiation of px with respect to x. Here lambda and mu are constant, right? Now, when we will be getting integrand of the form of p1x upon p2x in trigonometric function, then we will express p1x as lambda p2 dash x plus mu p2x plus phi, where p2 dash x is the differentiation of function p2x with respect to x, and lambda, mu and phi are some constant, right? Now, when we will get the integrand in the form of p1x upon p2x in arithmetic function, then we will express p1x equals to lambda p2x plus mx, right? Where p1x is also a function of degree 2 and p2x is also a function of degree 2, right? When we will be getting the integrand of the form h1x upon h2x, where the degree of h1x is greater than h2x, then we will actually divide the polynomial in this case, right? Now, first of all, we get the rule number 1, that when we are getting the integrand in the form of square root of mx, then we are actually putting mx equals to t square. Rule number 1. Rule number 2, when px come alone in expression, see, when px comes alone in expression, then actually you have to convert px to sx. And how we will convert from px to sx? Step number 1, make coefficient of x square in px equals to 1. How we will make it? Take the coefficient of x square from the bracket from all the terms present. For example, fx equals to 3x square plus 2x plus 1. Then how we will convert this px equal to 3x square plus 2x plus 1 to sx form? Here actually we are taking 3 from x square. We are taking out 3 from x square plus 2x plus 1. Then expression will become like 3 whole x square plus 2 upon 3 x plus 1 upon 3. Then actually we are putting p dash x equals to x square plus 2x plus 2 upon 3x plus 1, right? Now, we assume that p dash x equals to x plus a whole square plus p a square. When we expand this equation, we will be getting x square plus 2ax plus a square plus b square. Now, we will compare the coefficient of equation 1 and equation 2. Then, while comparing, we will get the coefficient of a equals to 1 upon 3 and a square plus b square equals to 1 upon 3. Right. So, here we will be getting b equals to a square root of 2 upon 3. Right. Now, equation becomes px equals to 3 into x plus 1 upon 3 ka whole square plus square root of 2 upon 3 ka whole square, bracket close, into 3. Now, put x plus 1 upon 3 equals to t. Then our equation h of t will become 3 into t square plus square root of 2 upon 3 ka whole square. This is in the form of ax square plus b. Right. Here b is a constant. Right. Now, rule number 3. When we are getting integrand of the form of mx upon px, here we will be putting mx is to lambda p dash x plus mu here. for example, px equals to x square plus 9x minus 5, then p dash x equals to d of px upon dx. It will be 2x plus 9, and we will put mx equals to lambda p dash x plus mu, and comparing the coefficient on both sides. So x plus 4 equals to lambda times 2x plus 9 plus mu. So x plus 4 equals to 2 lambda x plus 9 lambda plus mu. So when we compare the coefficient of x and constant terms, so we will be getting 2 lambda equals to 1. This implies lambda equals to 1 upon 2, and 9 lambda plus mu equals to 4. So when we put lambda equals to 1 upon 2, we will be getting mu equals to minus 1 upon 2. So mx equals to 1 upon 2, 2x plus 9 minus 1 upon 2. Right? Now, when we get the integrand of the form of p1x upon p2x, where p1x upon p2x is a trigonometric function. So here we will put p1x equals to lambda p2x plus mu p2 dash x plus 5. Here p2 dash is the differentiation of p2x with respect to x, and lambda, mu and phi are constant. Right? So for example, when p1x equals to 2 sin x minus 3 cos x plus 5, and p2x equals to sin x plus 2 cos x plus 7, here the differentiation of p2x with respect to x is differentiation of sin x plus differentiation of 2 cos x. It will be cos x minus 2 sin x. Differentiation of cos x equals to minus sin x, and differentiation of sin x equals to cos x. So when we will express p1x equals to lambda p2x plus mu p2 dash x plus 5, we will be getting 2 sin x minus 3 cos x plus 5 equals to lambda times sin x plus 2 cos x plus 7 plus mu times cos x minus 2 sin x plus 5. And here we will equate the coefficient of sin x, cos x and coefficient on both sides of the equation. So we will be getting lambda minus 2 mu equals to 2 lambda plus mu equals to minus 3, 7 lambda plus 5 equals to 5. Actually there we are having 3 equations and 3 unknown. So we will, while solving the equation, solving first and second, we will be getting lambda equals to minus 4 upon 5 and mu equals to minus 7 upon 5. When we will put lambda equals to minus 4 upon 5 in equation 7 lambda plus 5 equals to 5, we will be getting lambda 5 equals to 53 upon 5. Right? Now, rule number 5, when we have integrand of the form of p1x upon p2x, when p1x and p2x are arithmetic function, right? So we will express p1 as lambda p2x plus ax plus b. Here we are having example of p1x equals to 3x square plus 2x plus 1, and p2x equals to 5x square minus 7x plus 1. So we will express p1x equals to 3x square plus 2x plus 1 equals to lambda times p2x plus ax plus b. So we will be getting 3x square plus 2x plus 1 equals to lambda times 5x square minus 7x plus 1 whole plus ax plus b. So when we compare the coefficient of x square, x and constant term on both sides, we will be getting 5 lambda equals to 3. This implies lambda equals to 5.3. A minus 7 lambda equals to 2. So we will be getting a equals to minus 11 by 5. When we lambda plus b equals to 1 and lambda equals to 3 upon 5, we will be getting b equals to 2 upon 5. Right? Now, there are some standard results of integration. Actually, integration is basically inverse of differentiation, right? So actually we know that differentiation of x to the power n plus 1 equals to n plus 1 x to the power n. So the inverse of differentiation is integration, right? So हम यहाँ पे इंटीग्रेट करेंगे x to the power n का, so we will be getting x to the power n upon n plus 1 plus c. Here c is a constant. C is a constant. Integration x to the power n plus 1 divided by n plus 1 plus c represents family of curve, right? Similarly, the integration of dx upon x equals to ln plus x. Again, c is a parameter which is a constant, right? Now, integration of exponential function. Right. Integration of a to the power x into dx equals to e to the power ax upon a plus c. How? Actually, as we know, the integration is the inverse of differentiation. So, for fx equals to e to the power x, dfx upon dx equals to e to the power x, right? When we put ax in place of x, we will be getting d of f of x upon dx equals to a e to the power x, right? So fx equals to e to the power ax in this case. So df upon dx is to a e to the power x, right? Right? Now integration of dfx upon dx with respect to dx equals to a into integration of e to the power ax dx, right? So here we will be getting fx, and it is e to the power ax equals to a integration of e to the power ax dx. So we will get integration of e to the power ax dx equals to 1 upon a e to the power ax, right? Right? Actually, we will also assign some constant c in this case to get the entire family of this particular function, right? Similarly, e to the power integration of e to the power kx bracket kfx plus f dash x dx equals to e to the power kx plus fx plus c. How? We will substitute e to the power kx into f of x equals to t. Then we will get, when we differentiate these with respect to x, we will get e to the power k x f dice x plus k e to the power k x f x dx equals to dt. So e to the power kx kfx plus f dice x equals to dx equals to dt, right? So when we integrate these, we will get t equals to t plus c equals to e to the power kx f of x plus c, right? Similarly, when we put a to the power integration of a to the power x into dx, we will get a to the power x upon ln a plus c, right? How we will get this integration? How we will get this integration? Actually, we will take a to the power x equals to e to the power x ln a, right? And we will integrate from this root e to the power x, right? So we will be getting e to the power x upon ln a plus c. Now, the standard result of integration of trigonometric function is integration of sin x dx equals to minus cos x plus c. Actually, the differentiation of cos x is minus sin x. So, the integration of sin x with respect to dx will be minus cos x, and we will attach some constant c to get the entire family of the equation, right? Similarly, the integration of cos x dx equals to sin x plus c. Integration of tan x dx will be minus log mod cos x plus c. Similarly, integration of sec x into dx equals to log sec x plus log mod sec x plus cot x plus c. So, see how we will get the integration of sec x with respect to dx equals to this form. Actually, we will multiply numerator and denominator both by sec x plus cot x, and we will put sec x plus cot x equals to t, right? So, similarly, the integration of cosec x dx equals to log cosec x minus tan x plus c. In this form also, we will multiply both numerator and denominator by cosec x minus tan x, and then we will put cosec x minus tan x equals to t, right? Similarly, the integration of cot x dx equals to log mod sin x plus c. Integration of sec square x dx equals to tan x. Actually, the differentiation of tan x is sec square x. So, the integration of sec square x dx equals to tan x plus c. Right? Now, integration of sec x plus tan x into dx equals to sec x plus c. Actually, the differentiation of sec x is sec x into tan x. So, the integration will be sec x plus c. Similarly, the integration of cosec square x will be minus cot x plus c. Integration of cosec x into cot x dx equals to minus cosec x plus c. Inverse trigonometric function. Actually, we know the differentiation of tan inverse x equals to 1 upon 1 plus x square. So, the integration of 1 upon 1 plus x square dx equals to tan inverse x plus c. Similarly, we know the differentiation of sin inverse x equals to 1 upon a square root of 1 minus x square. So, its integration of 1 upon a square root of 1 minus x square will be sin inverse x plus c. Right? Now, integration of function of the based of sx. Sx is x square plus b. Right? So, rule number 601, dx upon integration of dx upon a square plus x square equals to 1 upon a tan inverse x upon a. Actually, we have seen that integration of 1 upon 1 plus x square equals to tan inverse x, right? So actually we will take a from this equation, we will take out a from this equation, we will be getting integration of dx upon 1 plus x upon a whole square into a square, right? So when and we will put x upon a equals to t, then we will be getting integration dx equals to a dt. So actually we will be dealing with equation of dt upon 1 plus t square into a 1 upon a square. So actually we will be getting dealing with the dt upon 1 plus t square into 1 upon. So integration of 1 upon t square with respect to dt will be tan inverse t. So t actually x upon a, so we will be getting 1 upon a x tan square tan inverse x upon a plus c. Similarly, the integration of dx upon a square minus x square equals to 1 upon 2a log a plus x upon a minus x plus c. How we will get this form? Actually, we will write 1 upon a square minus x square equals to 1 upon a plus x minus 1 upon a minus, right? Right? One upon a plus x plus 1 upon a minus x. So actually we will, right, into 1 upon 2a. So it will be, right, and now we will integrate this form, right. So we will be getting the integration of 1 upon a square minus x square equals to 1 upon 2a log 1 upon 2a log a plus x upon a minus x plus c. Similarly, the integration of dx upon x square minus a square equals to 1 upon 2a log x minus a divided by a plus x plus c. So actually in this case also we will put 1 upon x square minus a square equals to 1 upon 2a into one upon x minus a plus 1 minus 1 x plus a, and we will integrate this term individually and we will be getting this. Now integration of the form of dx upon square root of sx. What is sx? Sx is x square plus b. So actually when integration of 1 upon a square minus x square square root, integration of 1 upon a square root a square minus x square dx equals to sine inverse x upon a, right? How we will be getting this? Actually we know the integration of dx upon a square root of 1 minus x square equals to sine inverse x. So we will take out a from a square minus x square plus square root. We will be getting integration of 1 upon a square 1 upon a square into integration of dx upon a square root of x upon a whole square, right? So and finally we will put x upon a equals to t, so we will get this equation, right? Actually हम यहाँ से क्या करेंगे, we will take out a from this equation, we will take a from this equation, so we will be getting 1 upon a integration of 1 upon integration of 1 upon a square root of 1 minus x upon a whole square dx, and in this equation here we will put x upon a equals to t. So we will be getting integration of this equation is sin inverse x upon a. Similarly, the integration of dx upon a square plus x square to the power 1 upon 2, that is integration of square root of a square plus x square will be log x plus sx, where और हम इसको एक्चुअली क्या करेंगे, we will convert this equation to integration of dx upon sx, right? Then we will get the equation as integration as log x plus xx, log mod x plus sx plus c, right? Similarly, the integration of dx upon square root of x square minus a square equals to, we will convert this equation to sx form, right? And we will get integration as log mod x plus sx plus c, right? Now, integration of the form of a square root of sx into dx. Here in the previous section we have seen the integration of the form of dx upon a square root of sx. Here we will be dealing with integration of a square root of sx into dx, right? So actually the integration of a square root of a square plus x square dx, when we will convert this equation to integration of a square root of sx into dx, we will get the integration as 1 upon 2 x into sx plus a square log mod x plus sx plus c. When we are integrating a square root of a square minus x square dx, we will be getting 1 upon 2 x sx plus a square sin inverse x upon a. Here we will convert a square minus x square in sx form, right? Similarly, integration of x square minus a square to the power 1 by 2 dx, again we will convert this equation to sx form, and the integration will be 1 upon 2 x sin x minus a square log x plus sx plus c, right? Now, types of integral. What is types of integral? Actually, what is integral? What is integral? Integral. Actually, integral is a function which is inverse of differential, right? When we are getting the process of getting anti-derivative or anti-differential equation is integration. So there are basically 8 types of integral, right? These are monomial based. These are monomial based mx of the form of mx equals to ax plus b, a square polynomial based of the form of sx equals to x square plus b, polynomial based px equals to x square plus bx plus c, hybrid form mx and px based, like mx upon px or mx into px, trigonometric function based like sin x, cos x, tan x, and partial function based. A special form, there are some special forms, and integration by parts form, right? So when we will be dealing with px based, actually integration of when we will be dealing with integration of p into dx, actually we will integrate it individually. How? Actually, suppose px equals to ax square plus bx plus c. When we have to integrate this px dx, we will be integrating ax square plus bx plus c dx. Here we will integrate each of these terms individually, right? When we are having integration of the form of 1 upon p dx, right? Actually, here we will convert px to the form of sx, and then we will integrate this form dx upon sx for. So actually we have seen in the previous section of dx upon ax square minus x square integration, it will be getting 1 upon a tan inverse x upon a. When we will convert px in the form of a square minus x square, we will be getting the integration as 1 upon 2 a log a plus x divided by a minus x plus c. When we will convert px in the form of x square minus a square, we will be getting the integration of 1 upon 2a log x minus a upon a plus x plus c. When we are having the integration of the form of I equals to 1 upon a square root of p dx, here again we will convert px to the form of sx, and then we will be getting of the form of integration of dx upon a square root of sx. Here again we have seen 3 forms to solve the equation. So when we are getting the equation in the form of dx upon a square root of a square minus x square, we will get the integration as sine inverse x upon a plus c. When we will have the integration of the form of dx upon a square plus x square to the power 1 upon 2, we will get the integration as log x plus sx plus c, right? Sorry, this is right. When we will be getting the integration of the form of dx upon a square root of x square by minus a square, we will be getting the integral of the form of log x plus sx mod plus c. Here sx is the form of x square plus b, right? When we are getting the integral of the form of I equals to a square root of px dx, here again we will convert px in the form of sx, then our equation will become will come in the form of integration square root of x dx, and here again we have seen in the previous section the integration of the form of a square root of a square plus x square to the power 1 upon 2 dx equals to 1 upon 2 x as x plus a square log x a square log x plus sx mod plus c, right? Similarly, when we integrate a square root of a square minus x square to the power 1 upon 2 and integration of x square minus a square to the power 1 by 2 as per the previous section. Clear? Now, when we are getting the integration of the form of I equals to p1 upon p2, when we are getting integration of the form of integration of p1 upon p2 dx, here actually we are expressing P1x as lambda P2x plus m as discussed in the previous section. So when we are expressing P1x as lambda P2x plus m, then our equation will be I equals to integration of P2 and in the denominator of P2 it will be cancelled. So equation will be lambda dx integration of lambda dx plus integration of m upon P2 dx. So we will be getting two integration, right? So we integrate lambda dx individually, and we will integrate m upon P2 dx individually. So we will again express m as lambda P2 mu P2 dash plus phi. Here mu and phi will be constant and P2 dash will be the differentiation of P2l, right? So again we will be getting integration of mu P2 dash upon P2 dx plus integration of phi upon P2 dx. So here phi is a constant, so we will get the integration of the form of 1 upon P2 dx. So here it will transfer to the form of this equation, and 1 upon P form will be transferred to integration of 1 upon Sx form, right? So actually here for this portion we will be dealing with the form of this, and here we will put P2 x equals to then P2 dax dx will be dt. So actually here we will get log mu log P2, and the integration of phi upon P2 dx, we will use the rule to 6 not to 1 to 6 not 3, right? Now here in the rule 2 we are converting actually px to sx, right? So actually this is the summary of the previous section of when we are getting the integration of the form of px, where px is in the denominator in the form of inverse of a square root, when we are getting a p1x upon p2x form. Then these are the methods we can apply, right? No. Here we have in the previous sections we have seen how to convert px to sx, how we express mx as lambda p dash x plus mu, and how we express p1x is to lambda p2x plus mx. Clear? Right? Now, hybrid function. In this type of integration, actually we will be getting integrand of the form of m upon p, or integrand of the form of mx square root of px, or integrand of the form of mx upon square root of px, or integrand of the form of 1 upon mx into square root of px, or integrand of the form of 1 upon px square root of mx, right? So when we are getting integrand of the form of m upon p, here actually what we will do, actually here we convert m, we express m as lambda p dash x plus phi, and we solve accordingly, right? And we will apply the rule of 6 not 1 to 6 not 3, right? When we are getting integrand of the form of mx square root of px dx, again what we do here is we convert mx, we express mx as the form of lambda p dash x plus mu, right? Right, and we apply the rule 6 not 7 to 6 not 9, where the 6 not 7 rule, where in the 607 to 609 rule we are getting the integration of the form of a square root of sx dx, right? So when we are getting the integrand of the form of mx upon square root of px, actually we will apply the rule 3 and the integration form of dx upon a square root of sx, and we will apply the rule of 604 to 607, right? So when the another is when we are getting the integration of the form of 1 upon mx square root of px, this is very important. When we are getting the integration of the form of 1 upon mx square root of px, here actually we will put mx equals to 1 upon t and we will proceed, right? When we are getting integration of the form of 1 upon px square root of mx, here we will put mx equals to t square and we will proceed, right? Trigonometric based function. When we are having integrand of the form of 1 upon number 17, when we are having integrand of the form of 1 upon a sin x plus b cos x, actually we will put sin x equals to 2 tan x upon 2 divided by 1 plus tan square x upon 2. Actually we know that sin 2 theta equals to 2 tan theta upon 1 plus tan square theta. So here in place of theta we will put x. So we will be getting sin x equals to 2 tan x upon 2 plus 1 plus tan square x upon 2. Similarly, we will put cos x as 1 minus tan square x upon 2 plus 1 plus tan square x upon 2. Actually here again cos 2 theta equals to, we know cos 2 theta equals to 1 minus tan square theta upon 1 plus tan square theta. So in place of 2 theta we are putting x, so we will be getting 1 minus tan square x upon 2 plus 1 upon tan square x plus 2, right? When integrand are in the form of a sin x plus b cos x plus dx upon d sin x plus e cos x plus c, actually we have discussed this form in the previous section of rule number 4. Actually we will be expressing p1x equals to lambda p2 dash x plus mu p2x plus 5, and we will proceed as per rule number 7, right? When we are getting integrand of the form of sin nx plus cos mx, actually we know that sin a plus b plus sin a minus b, when we break these, actually we will be getting sin a cos b plus sin b cos a plus sin a cos b minus sin b cos a. When we will add this, we will be getting 2 sin a cos b. So here we will multiply numerator and denominator by 2, and we will take 2 sin nx cos mx. We will getting sin nx plus sin n plus m cos x plus sin n minus m cos x dx, and we will integrate individually. The integration of sin to the power n x plus cos to the power m x dx. In this section, we will put sin x equals to t if n is odd. When n is odd, we will put cos x equals to t, right? If m plus n is negative, suppose m is minus 7 and n is 2, then m plus n will be minus 5, right? So when m plus n is negative, we will divide numerator and denominator both by cos x to the power cos k x, right? Here k equals to m plus n. For example, integration of sin square cos minus 7x dx. Actually here m plus n equals to minus 5. So we will multiply both numerator and denominator by cos minus 5x, right? So we will get right. So we will get the form of sin square, cos minus 12 x upon cos minus 5 minus 5x dx, right? Right? Now when we are getting the integrand of the form of 1 upon a square sin square x plus b square cos square x, here actually we will divide both numerator and denominator by cos square x, and then we will put tan x equals to t. So here actually when we divide by cos square x, we will be getting the integrand of the form of 1 upon a square tan square x plus b square, right? And we will be getting in the numerator as sec square x. So when we put tan x equals to t, we will be getting sec square x dx equals to dt, and we will get the integration of the form of dt upon a t square plus b square, right? So here we are converting this to the form of sx, and we will getting the result in the standard form, right? In this special form, when we are getting integrand in the form of x square plus 1 upon x to the power 4 plus lambda x square plus 1, or x square minus 1 upon x to the power 4 plus lambda x square plus 1, or 1 upon x to the power 4 plus lambda x square plus 1, we will be dividing both numerator and denominator by x square, and we will put x plus 1 upon x upon t, or 1x minus 1 upon x equals to 1 upon t depending upon numerator. So how we are saying that, consider the first case, integration of x square plus 1 divided by x to the power 4 plus lambda x square plus 1 d. When we are dividing both numerator and denominator, the equation, the integration will come to the form of 1 plus 1 upon x square dx divided by x square plus lambda plus 1 upon x square. Right. So here we will be putting x minus 1 upon x equals to t, then we will get 1 plus 1 upon x square dx equals to dt. We will convert this to x plus 1 upon 1 plus 1 upon x square dx divided by x minus 1 upon x whole square plus lambda plus 2, right? So here we will put x minus 1 upon x equals to t, then we will get the form of dt upon t square plus lambda upon 2, and we will very easily we will evaluate the integration, right? Now the partial fraction, actually when we are seeing the integration of 1 upon x square minus a square, actually I have done there, I have expressed the form of 1 upon x square minus a square as 1 upon 2a 1 upon x minus a plus minus 1 upon x plus a, and accordingly we have got the integration as 1 upon 2a log x minus a upon a plus x plus c. Here when we are getting the integrand of the form of 1 upon x minus a minus x minus c, actually we are when we do the partial fraction of 1 upon x minus a into x minus c, we express this in the form of a upon x minus a plus b upon x minus c. When we are getting integrand in the form of 1 upon x square x minus a whole square into x minus b, we express the partial form of 1 upon x minus a square into x minus b at a upon x minus a whole square plus b upon x minus a plus c into x minus b, and we integrate individually all these terms. Actually we are putting this x minus a2 whole square to x minus b. We are doing partial fraction of 1 upon x minus a whole square into x minus b. When the integrand is in the form of x square minus a into x minus b, we do the partial fraction of 1 upon x minus a x square minus a into x minus b as ax plus b upon x square minus a plus c upon x minus b, and we integrate by finding out the value of a, b and c. We integrate these terms individually, right? Similarly, when we are getting the terms when we are getting the integration in the form of 1 upon x square minus a into x square minus b, we can do the partial fraction of these terms in the form of ax plus b upon x square minus a plus cx plus d upon x square minus b. When we are getting the form of x square minus a whole square into x minus b, actually we are when we are converting in the partial fraction, we are getting in the form of x plus b into x square minus a to the power whole square. Whole square into cx plus d upon x square minus a plus a upon x minus b, right? Now, integration by part. When we are getting the integration of fx into sx dx, when we are having two functions simultaneously, when we have to integrate this function, then actually by considering fx as a first function and sx as a second function, we are integrating we are taking first function as a constant and integrating second function, and after that we are subtracting this by integration of differentiation of first function into integration of second function into dx. Actually, integration of fx sx into dx equals to fx into integration of sx dx minus integration of f dash x into integration of sx dx to the dx. So actually, how we will decide the first function and second function? For deciding first function and second function, we apply the method of ILAT, inverse function, logarithmic function, arithmetic function, trigonometric function, and exponential function. Right. So first function, when we are getting the function as a says logarithmic or arithmetic, by applying the rule of ILAT, we will consider first function as a logarithmic function, right? When we are getting arithmetic and exponential function, we will consider arithmetic function as a first function and exponential function as a second function, right? Now, for example, integration of x square into sin x dx. Actually, when we apply the rule of ILAT, actually arithmetic function is getting we will take as a first function, and trigonometric function we will take as a secondary function, right? Thank you very much.